ಹಾಗೆ ಮುದ್ದೆಲ್ಲ ಮಾಡ್ಬಿಟ್ಟು ಮತ್ತೆ ನಾಳೆ
Hi guys, good evening all. So hope you guys are doing good. So you guys have any questions or all good for yesterday's? So today's session, we are actually going to start with Arduino programming. Okay. So I'm not sure about how much I can able to give this hardware part, but I can give assurance that we can able to have a good hands-on in your coding part. Okay, because as we are connecting in online and as we are just going ahead with the concepts of coding and hardware, so we'll focus more on coding because hardware is the part. As you guys are from electronics background, hope you guys can easily handle it, because when we are giving a circuit diagram, you need to assemble the hardwares with the help of circuit. So those kind of things you guys can easily handle. So when it comes to coding part, probably it may be a little difficult for you guys. So we'll be focusing on coding part, and I will be just sharing the circuit diagram of the particular coding, and I will give the working principle. So you guys will get some basic idea. So Arduino. So yesterday we discussed about basic introduction about Arduino. So today what we are going to do here is in depth of Arduino. So connecting the sensors, and then probably connecting a Bluetooth, and then probably how to write a code in Arduino IDE, and what are the kind of boards and how to choose Arduino boards. Those kind of things we are going to discuss now. So this is all the stuff that we are going to discuss for today. So when it comes to your Arduino, so as we already aware of, your Arduino is an open source prototype. So which is actually used to develop your IoT automation kind of things. Okay. So when you are just going ahead with your Arduino, uh, it is a ready-made kit. We don't need to build the circuits or build anything for Arduino. It is a ready-made kit. So you guys can simply buy, and you guys can simply assemble the circuits, and you can connect with your system as well. It's there is no much connectivity or much uh, drivers are needed for Arduino. So as you are installing Arduino itself, Arduino automatically install with all this kind of pre-built Arduino libraries and all those things. So when we are just going for Arduino projects, it was actually going to help you for Arduino C programming or Python or AVR boards. We have a lot of programming languages. About programming languages, we'll be discussing in later stuff. So as of now, we are just going to discuss from Arduino C. Hope you guys have a basic idea about C programming. So like normal data types, those kind of concepts. So we are now going ahead with Arduino C, which is a C programming only, but it's going to support your Arduino software. So that's the difference. So nowadays, Arduino boards is actually coming with the support of Python programming as well. So when we are going for Arduino, you can choose C or you can choose Python. Apart from, you can choose MATLAB as well. So some kind of programming languages supports for your Arduino boards. So, so the futures of Arduino, hope yesterday as we already discussed. So what we are actually going ahead with this is, it will have analog or digital converter. So it's having, you can able to get analog input and you can able to give a digital output. You can able to do the vice versa things. So all those things we can easily handle with the help of Arduino. So your Arduino is a microcontroller, not the microprocessor. So if it's a microcontroller, so we don't need any extra peripherals. So you having an Arduino board is more than enough. Apart from input output devices all main needed for us. So your Arduino IDE is nothing but C++ version. So it's exactly a C++ version of your version is your Arduino IDE, and it's a open source. Open source is free to use. So we are having a various type of boards in Arduino. So depends on your need. You guys needs to choose your boards. So how to choose the best board for our projects? That's a very important thing. So when you are just going ahead with the very best board, based on your operating system, number of inputs, and then clock speed, and then frequency. This all some factors we always needs to consider when we are designing any kind of circuit. Not only for Arduino, even if you are going for any other embedded devices like PIC controller, or if you are going for AVR, so or Arduino, Raspberry Pi, whatever itself, you guys needs to always think about the boards frequency, clock speed, and then number of inputs which is acceptable, number of output. So all these things we need to always think in your mind. So this are the main criteria before you are selecting the board. You guys needs to always think about. So when you are going for board types, so we are having a different kind of clock speed and different kind of digital IO, and we having analog inputs, and then PWM, UART, programming interface. So programming interface in Arduino, it's not going to make a much difference. But when we are going for the normal PIC controller, or when we are going for some other controllers like AVR, ARM, this programming interface was actually a kind of big drawback that times. So sometimes we need some extra peripherals to connect the programming with the system. But our Arduino, the programming interface is simple USB only. It's a kind of USB cable only. So we will be getting that cable along with the Arduino board itself. So we don't need to worry about. And advance of Arduino, which consists of ESP8266, those kind of things will be coming ahead with the normal Samsung charger itself. So programming, interfacing with the devices is not that much complicated for us. So you guys can simply go ahead with your any kind of programming interface with our Arduino. So when you are going ahead with Arduino boards, mostly voltage. Okay, so operating voltage, the input voltage, it's 5 volt, mostly 3 to 5 volts only. It's common for all the boards. All the microcontroller is actually the same kind of thing. So then clock speed. Clock speed is very, very important. For any microcontroller, it's very, very important. So as you guys know what is clock speed, right? So it's a kind of performance. So your system performance or any kind of performance is actually based on clock speed only. So when you are going for your 3.2 gigahertz, if it's 3.2 gigahertz clock speed means it's going to execute 3.2 billion cycles per second. So we are going to measure the speed of the CPU with the help of clock speed only. Sometimes we use it to tell us a clock rate or frequency, those kind of things we used it to tell. So you are generally this clock speed by general, it's a kind of CPU only. It is actually going to make kind of CPU only. So in many factors, okay, in many factors, your clock speed will, we always think about clock speed. For example, purchasing a laptop, and then even purchasing mobile. So we always needs to think about clock speed, because when you are processing your CPU, many of the instructions will be handled, will be shared with the help of clock speed only. So when we are going ahead with your so for example, if this is a clock speed means, so this number of cycles, so per second, how many number of cycles we are just going to pass, that's what your clock speed is. So increasing the clock speed, we can able to go ahead with your we can able to go ahead with the more speed. Okay, so that's the reason we are actually thinking about clock speed. Then digital IO, so digital input output. So this digital input output is actually uh, this digital pins, which is common for input and output. You can use the input, and as well as you can able to use the output as well. And then when it comes to analog inputs, we are just going to give only inputs to analog pins. So we used to tell us your analog inputs only. So how many pins? So 6 pins. So if you are choosing UNO or Pro, it's all be considering as only 6 pins. But when we are going for your Pro or some kind of advanced boards like Mega and all those things, we use, that's all inputs is higher. So then PWM, mostly you will be getting 1, 2, 3 like this only. So anyhow, that's not a problem. And then when we are just going ahead with the next part, programming structure. Before the programming structure, we need to start with the installation and how the programming, the software will works. So again, coming back to selection of Arduino board. See, when you are selecting your Arduino board, if you are planning to give 2 or 3 inputs, normal Arduino Mini or Arduino ENO is more than enough. But when you are going to give a multiple, more than 5, 6, 7 kind of inputs, we always prefer a Mega or Lilypad, those kind of boards we used to prefer. So depends on your need. So depends on the requirements, we need to choose your board. So this is actually common for all the microcontroller based projects. So when we are kickstart with any embedded projects, when we are kickstarts with any embedded projects, we need to always discuss, and we always needs to choose the board based on input output, and then clock speed, and then your PWM signals, how the particular controller is going to handle the PWM signals. So these are some factors that we always needs to discuss. Okay. So any doubts? Okay. Why operating voltage 3.3 volt only for microcontroller? Okay. See, your normal mobile itself, when we are actually connecting with AC, okay. So your chip, it may be any kind of chip, okay. So this any kind of chip by default, it will handle 3.3 volt only, okay. The reason being is always we used to get the digital only. So the digital inputs we always make for this till 5 volts only, okay. Mm, so in other words, how we can able to tell here is, we can tell all your circuits, okay, will comes with noise susceptibility, okay. So when you are going for the noise level, if you, it won't support more than 5 volt, okay. So when you are just going ahead with your electronics component, we always used to perform based on analog signals only. So then we used to get your digital output only. So for those kind of conversion, your digital output, those kind of things, your power will handle only till 5 volt. If you are giving more than 5 volt, it will definitely blast. So that's the reason we are having a separate adapter for even our mobile charger. Your mobile charger also, it's going to get only that much level. So all the microcontroller, due to this noise compatibility and due to this conversion, for those kind of things, we'll be just going ahead with only 5 volt, because you will be going to give an analog input and will be going to get a digital output. So all this kind of signals will accept only the low voltages. Still you can able to give till 12 volts, okay. But that's not advisable, because the reason is, when you are going ahead with your 12 volt and all those things, normally your Arduino, it won't handle till 12 volts. The reason being is, your Arduino is low in handling the temperature and all those things. So if you are giving even 12 volts, it will definitely get burst. So for that perspective only, your Arduino is actually restricted till 5 volt. Even we won't prefer 5 volt as well, we used to give 3.3 volt only, because if you are giving more than that, this digital signals won't adapt to this. So for that perspective only, all the microcontroller are designed to handle 1 till 5 volts only. And we can't able to directly give our 120 volt or something to our controller. So your digital kind of things, it won't handle those things. So giving a more than 3.3 volt is not advisable to any kind of microcontroller. So that's the reason. Okay. So if in case if I am giving a more than 5 volt or less than 5 volt, we do have a resistor and we do have a voltage regulator as well, but still the voltage regulator is not that much sufficient to control the more voltages. Okay, so that's the reason we will be giving only 3.3 volt to our Arduino. So that's the reason, nothing else. Okay, so as we already discussed, your Arduino is an open source. So let me share one more screen where you can able to download your Arduino. 1 minute. So Arduino, just simply searching Arduino in your Google itself, it will redirect to one page. That's nothing but Arduino CC. So when you are going for this website is a official website for your Arduino. So here, if you are going for the hardware, you can able to find out what are the exact hardware that's actually available. But now we are just going for the software part. So if you are just going for software, you will get Arduino Create. So let's see go for Arduino Create. So I think recently they launched some web editor and IoT Cloud and Message Manager for Linux Digital Store. This all the things they actually recently launched, I guess. So you can just go here and there is an online IDE. So clicking this, it will redirect to your online editor. So when you are just going ahead, it will ask you to log in. So you guys can log in and you guys can able to develop the code even in online itself. Mostly in industries, we won't create in online IDEs, we won't prefer. So I'm just going for this downloads. So when you are going for the downloads, so here we have even if you are going for downloads itself, it will give code online. So you guys can go ahead with this. Otherwise, this is all that environment that you can able to install. So this is for zip file, and this is for without zip you will directly get exe. So don't download the application. You guys can simply give this thing, so it will redirect to the next page. So just download, that's it. So your download will get starts. So it will actually downloading the latest version, that is nothing but 1.8.13. So it take only less than a minute. So if you guys want, you guys can download it. Otherwise, what I will recommend is you guys just to go ahead with the online IDE and just give sign in with the Google. So it will go for the Google authentication. So just giving the things, you guys can easily start to code in online itself. Okay, because now we are just going ahead with your normal code development part. So I will request you guys to either to download or to open it in online. That could be much better for us. Okay, so after it's downloaded, just give next. Once its installation gets complete, it will ask you like, can I install some driver on your system? Just give yes for that, because without the drivers, you could not able to connect your Arduino board with your Arduino IDE. So that board is very important. Okay. So as I already having an Arduino, I didn't install it. So let me share the Arduino ideally with you guys. See, the maximum power it can hold without fail is only 5 volt. We could not able to give them more than 5 volt. The minimum is 3.3, maximum is 5 volt. That's it. Even in if you're going ahead with some Arduino board, even that Arduino board itself consists of only 3.3 or 5 volt of pins only. We don't have more than that. So we can able to go ahead with only that much, not more than that. Okay. So this is Arduino ideally. So this ideally looks like this. So when you are going for your Arduino ideally, it's an open source. So you guys can code in online, either you can download here. So simply giving a file, new file, it will open a new file. So see here, by default, your Arduino ideally, it's coming with two different structure. One is setup, another one is loop. Okay. See this setup, it's actually going to initiate something for you guys. And this loop, it's going to hold the main block. Okay. So without this two structure, we can't able to write any program in your Arduino. Okay. So to start with Arduino, the very first thing is you guys needs to be aware of C program. So I hope you guys already having your C programming background. So when you are just going ahead with this setup is going to execute only in the initial stage of your project. It's not going to execute in all the level. Loop means it's going to respond and it's going to make a decision and it's going to allow some changes in your program. Okay. So these are the libraries. So like ash includes standard io.h, console io.h. We are having some kind of library. The syntax is same like your C, C++. Ash include, and in that angle bracket, we are giving a library. So here I am giving an ash include, then I am just giving, this all some kind of library that's actually available. So this Ethernet, DHCP, DNS, this utilization, this all some libraries which mainly used to connect your Arduino with Wi-Fi. The previous versions of Arduino will comes without Wi-Fi connectivity. So what we used to do is we used to get a Ethernet shield. So for to handle the Ethernet shield, we need this Ethernet client, Ethernet server, and all those things. Okay. So when you are going ahead with the other things, so later on other things like Zigbee, Bluetooth, we do have other libraries as well. So if you want to handle Arduino with a particular communication device, first you guys needs to understand which device is needed for this. Okay. So these are the things first you guys needs to hold it out. Okay. So the next thing is commenting in Arduino. That's exactly like your other stuffs like C, C++. So single double slash which is used to make a single line, like a slash asterisk which is used to make the multi lines, and then data types. So void keyword we do have like a C program which is used for your function declaration. Python same means like you are asking about syntax structure or the same ideally, because for to connecting with Python we do have a different steps. Along with Python, I'm just going planning to discuss with Raspberry Pi. Python is not same in syntax. Okay, Python is totally different. But to connect your Python with Arduino, we use ideally of Python and this Arduino IDE as well. We use it to integrate the two things and then we will execute. So even the execution is different and the syntax also different, but structure is same. Even in Python, first we used to initiate everything with the help of the setup kind of things, but we won't use a void keyword there. We used to write a Python syntax to handle the things. Okay, so we used to handle the Python syntax in your Arduino ideally. So we will write a Python variable declaration, everything, and then we will handle. So we could not able to tell both are same, but the steps are same. The flow is same. Like first initiating the variables and then connecting with the digital input and analog output. Those kind of things are same here. So that things are same. So when we are just going ahead with your data types in our Arduino, see we have a Boolean. Boolean means true or false. So apart from if you are just having something like unsigned characters, byte, unsigned integer, integer, float, we have a same data types which is available for your C programming. The same things exist for Arduino C as well. So when you are going for function declaration, we can able to declare the functions in this following way. One is return, function return. The another one is function type. The another one is function argument. So by using these three things, we can able to return the functions. So these are the basic introduction about the structure of Arduino. Let's we go and discuss about how to write a code in this Arduino ideally and how it will help for you guys. Okay. So I hope you guys are aware of LED. So this is an LED schematic diagram. So we have one anode, we have one cathode. So this is how your LED looks exactly. So we have one anode and we have one cathode. So now we are just going to write a script to connect your Arduino board along with LED. Okay. So what it's going to do here is, see, when I am just connecting these things, so positive of my LED, I am just connecting through my I'm just connecting through my pin, and the negative I'm just connecting through my ground. So after I connected, I'm just using a resistor, but uh, as a professional, we always include resistor. Okay, but practically speaking, as a student, okay, as you guys are going to execute, you guys are not going to connect with any power supply, or you are not going to connect with any other adapter. You guys don't need resistor, okay, because you guys know what's the purpose of resistor is. Resistor is used to resist that current. As you are connecting directly through laptop, you are just going to get only 5 volt, the same level of 5 volts or less than 5 volt only. So again, giving a resistor, it's no need when we are directly connecting your Arduino with laptop using the USB cable. Otherwise, if you are going to connect with some voltage, some adapter, or you are going to connect with power supply, then I would recommend go ahead with some resistor. So that's the thing. So when you are just going ahead with the normal circuit diagram here, see, I will just zoom in. So we are just connecting your ground with your negative terminal of LED, and the positive terminal of LED is connecting with resistor, but it's optional as I told. So when you are just going ahead with this positive, I'm connecting with 13. Okay. So 13 I'm giving for positive, and this negative I'm just giving for the ground. Okay. So here we have two things. One is void setup and another one is void loop. Okay. So I'm giving an integer variable name. So this is actually a variable name. So this, instead of this LED, you guys can give anything equal 13. Okay, so let me just execute here. See, here I'm just going to give integer variable name. So this variable is going to hold the integer data type. So that's the reason I give integer variable name. If it's going to hold some float or something, we used to tell that as a float variable name like this. I just given a pin number. So this is a pin number. Okay. So in case I want to connect the positive terminal to my 8 or 7 or 6, then I need to give that pin number here. Okay. So your positive terminal to which pin you want to connect. That pin I'm just defining here. Okay. So, and then see, in void setup, void loop, we have two things. As I already told, the setup is used for initiating something. Okay, so what we used to initiate in the circuits, either we will tell what are the inputs that you are going to use, then we will tell what are the kind of outputs we are going to use, and then we use, sometimes we used to tell the sensors, and then sometimes we used to tell about this output LEDs or something we used to tell about. So those kind of initiation we are just going to give in the setup. So this setup is mainly used to handle your initiating purpose. So what kind of input, what kind of output that you are going to handle, we are just going to handle in the setup. So when it comes to this loop, so this loop is going to hold the logics. So I'm telling you, my LED needs to switch on, switch off, switch on, switch off. So this is the I am expecting code from you guys. So what you guys needs to do is, first you guys needs to tell what's your LED pin. My LED pin is 8 here. I just initiated. Okay. Now I need to tell this LED is an input or output. Okay. So this pin is a input or output. So those kind of things. So this pin is an input or output. Those kind of things I need to initiate in my setup. Okay. So what I'm just giving here is a pin mode. It's a keyword. Okay. So what this keyword will do is, this keyword will give you this particular pin what kind of mode, either it's an input mode or it's an output mode. To tell those things, we are going ahead with these things. So what I'm just going to given here is LED. So this LED is a variable name which I declared here. So instead of here, I can directly declare as a pin number as well. So here I'm just giving a variable name, and then I'm giving an output. So in case if I am giving an input, then this 8th pin will be considered for input connection. Okay, but usually LED is used for only output, not for input, so I am just giving output. So setup, which is used to tell either the particular pin is for input or output. So the next thing is I'm just giving a digital write. So this digital write is a keyword. Okay, what it's going to write or what it's going to give to the pin. So digital write is a keyword what your controller is going to give to the output or to the input, or what kind of thing it's going to process in the particular pin. So to tell those things, we have a keyword that is nothing but a digital write. So how your controller needs to process, or what kind of process you guys are expecting your controller to do, what kind of logic your controller needs to execute, those things we need to define in void loop. Okay, so in digital write I'm just giving an LED. So this LED, that's nothing but a 8th pin, and I am giving a high. Okay, so that means my LED will be high all the time. High means 1, 1 means on. So what it will do is my LED will be switch on for it will be simply switch on. Okay, it, when I'm connecting and I'm uploading this, it will be switch on for the entire process until I switched off it. Okay, so it's going to be switch on till this complete. So this is a basic structure: void setup, void loop. So in setup you are going to give what kind of pins and what kind of mode that the thing is. In void loop, the pin is going to write how or what, that's we are just going to handle in this loop. So here we have this tick symbol, no? This is used to verify. Verify means is there any error is there. So we used to tell this, we used to handle the thing. So as I'm just saving, you can save anywhere of the system. So when I'm just compiling the sketch, here, this black color window is your output console. So this is actually executing the shell. See, when it's executing, we need to do one more thing. When you are just going for a file, we can able to go ahead with your normal new file, those kind of things we can able to do here. When we are just going ahead with the next things. Okay, so when you are going for a edit, we have a copy, paste, go to the line, and then those kind of edit options are there. And this is used for verify, compile, upload. And this tools, in this tools we have something, okay, the boards. So before we are compiling, we need to select the board as well. So for what kind of board, I'm just writing this code. Okay, so I am writing the code for the board in the tools for the boards of my Arduino UNO. Okay, so for my Arduino UNO, I'm just writing this code. So that's the reason I'm just I need to select the boards as well. So now it's executing for Arduino UNO. So it's giving some other error. 1 minute, let me check what's the error is. Yes, so compilation done. Okay, so the problem here is I just forgot the semicolon, so that careless mistake. So we need to use the semicolon as a C language, it's mandatory for us. So when we are just having these things, the compilation is done. Okay, so as the compilation is done here, we will get done compiling, and here you will get sketch uses how much bytes and how much of storage it's occupied, and the maximum it's going to lead with how much bytes. So those kind of things we used to get. So after it's compiled, here you have an upload option, but for uploading this thing we need to connect with Arduino board. Okay, so that Arduino board connectivity and all those things are hardware. You guys needs to get the Arduino board. and then you need to use the USB cable to Arduino on this thing, so you can easily upload it. Simply giving upload, it will start to upload, but now it will give you the error because the error is I'm not having this kind of board there, so it will give the error. So just you guys can just simply understand how to write the code and just to understand the flow. So in future, if you guys get chances to work with the board, you can able to do the program. And here, this is the circuit for this, so you can simply assemble and you can able to do this. And this is that, so here we have one connectivity port. So this connectivity port, by using the USB cable and Arduino programming interface, that UART, we can able to connect the two things together. Okay, so when I want to go for the next thing, see, when I give a high, it will be always high. That means it will be always in one. So it will be switch on my LED. Now I want to blink LED. Okay, blinking an LED. So I'm just giving a delay. So this delay I can give for 500 or I can give for 1000. So when I'm giving 1000, that's 1 second. So delay 1000. That means this high will be holded for 1 second. Okay, so then I'm just giving a low. So then this low will be holded for another 1 second. Okay, so if I want to write something, if I want to make a LED blink, LED is blink for 1 second. That means high, switch on for 1 second. So delay means it will hold or it will sleep. The process will be delayed for 1 second like this. Then low, I want to make the delay for 5 seconds, and I want to make LED to switch on for 5 seconds, and the switch off for 1 second means then I can give here 5000. So if I am giving on 5000 here, then LED will be switched on for 5 seconds, then switch off for 1 second. So this LED blinking, we can able to write something like this. And as you are using only one LED, you can simply giving LED pin, so positive to this pin, which whatever you declared here, and the negative to the ground. That's more than enough. Okay, so this error happens because I'm not connecting with any board. That's the reason we are having this error. So you guys don't need to worry about this error. So any doubt in this? See, high is not a predefined variable. We can't able to make anything as a predefined variable. Okay, variable means identifier means something which is declared by user only. So we can't tell is a predefined variable. It's a predefined keyword which is to be an high means 1. We can't able to directly assign high is equal to on. The reason being is on, again, what is the purpose of on? Your Arduino, it won't understand the things. So you can able to use high, low only. High means 1, low means 0. Zeros and ones only we can able to define. Now the error has happened because of semicolon only, not for inside the loop. Because inside the loop, it's used to make only the logics, those kind of things. Okay, so loop is used to write the logic, setup is used to giving the setup. Okay, so now I will give you 5 minutes time. Okay, application installation process. Okay, see, there is no need of final switch off LED in the project because we could not able to switch off the process. Okay, if you want to switch off the process means you can just remove the delay, so it will be off for end till end. Okay, see, there is a light. If you switch on, the light will be switch on. So if you are just switching off that LED, if your light is off, your light will be turn off. So same, if you want to disconnect your Arduino, you need to do manually. Okay, but here the concept is I'm telling blinking the LED. So on off like this. Okay, if you want to make only one on and till everything will be off means you don't need to give the delay. So that's the concept here. Okay, So now I will explain how to install this application again for one more time. I will explain 1 minute. See, you guys can simply go ahead with this software. Okay, in this software, so first to go to Google, simply type Arduino download or something, simply type. So you will be redirect to this Arduino .cc. So if you are just clicking this, you will redirect to this Arduino official website. So there is two options. One, you can give code online. So you will get the IDLE in code in online editor itself. So if you guys don't have a time to install, or if you could not able to install, you guys don't need to worry about the installations. Simply click on this code online and log in with your normal Google account itself. You can start to write the code. Okay, the same kind of structure will be happen there. Otherwise, in this Arduino IDE, okay, here you can just give a Windows, this summon a new year. So when you are just clicking this, it will redirect to another page. So in this, just download. So it will start to download. Okay, it's only 112 MB only, so it will take less than 1 minute. Android. I'm not sure about the application for Android, but we can able to open your Google there, and you can able to connect with your Chrome, and you can able to process the thing. So that is actually possible. Yes, of course. We need to connect with your physical device with your Arduino to see the output. Okay. So as of now, you guys can able to be an expert in writing the code. We need the physical device for the hardware setup. Without the physical device, we could not able to do anything. So for that perspective only, for the physical kind of things only, we are actually, I just is sharing this kind of circuit diagram. So this circuit, you will be getting a positive, negative pin. So if you are just connecting with the positive and negative, then we need to give a upload, so it will works fine. So this is the things that we can able to do here. Okay. So now virtual connection. See, virtual connection means we can't able to make any kind of virtual design, but we do have some kind of simulation software. Okay, but the simulation software will make the virtual design, but all those simulation software are little expensive. IBM is giving some simulation software for the two execution of the things, but that's all paid version. Okay, so if you want to see the you can able to simply design the circuit by using a fritzing, but the virtual output you need to pay and get the simulation software. So instead of paying and getting a simulation software, you guys can simply go to market and get a Arduino board itself, which cost only 400 or 500, and LED sensors, those things, so you can able to get the output to be done. Okay, so now, so difference between Node MCU and Arduino modules, that I will explain later, because tomorrow is your Node MCU session only. That time I will explain. Simply telling, Node MCU comes with inbuilt Wi-Fi module, but Arduino, it doesn't. It's a this was the previous different. But nowadays, even your Arduino is also coming with your inbuilt Wi-Fi only. Apart from, your Node MCU consists of different digital input and analog input and digital output. Pins are different, and the clock speed, those kind of things also little bit different. So that's the difference. So okay, now I'll give one small assignment to you guys. I will give 5 minutes time. So we'll give now 7:48. I will give exactly 7 minutes time to you guys. So this code, okay, so this code which I just done for only one LED. So this is the code. Now the assignment for you guys is, you guys needs to write for 5 LEDs. So first LED needs to switch on, switch off, then second LED, then third, then four, then five. So this kind of five LEDs, even if you can't able to make a five LED means only two LEDs. Okay. So this code is for only one LED I written. The same, I will give the hint. Define one more LED pin and do the digital write high and low for how many LEDs you guys are writing. For that, if you are just writing the digital write again and again and again by using the variable name, you can achieve it. Okay. So this is your first task in our session. Uh, your time starts now. Just try in this online editor, or if you guys install this Arduino ideally, you can go ahead. See, compilation errors matters here, but this error is happens not in the compilation. When I give a upload, this error happens. But when I compiled, we didn't have any error. That one error we got because of semicolon. I put the semicolon, so there is no error in the code. We get this error because I didn't connect my board, but I give a upload. That's the reason we get this error. Guys, don't need to share in this chat. Simply try by your own. After 5 minutes, I will share the code with you guys so you guys can clarify your code. Okay. So because I need the complete structure to be declared. You should not give first a digital write, digital write. First, you need to start with that void setup. Then you need to go for a while loop. So those kind of things we need to define. See, you guys can use online compiler. That could be fine. Or if you are using your, if you already having this ideally to be installed, you can use the same thing, not a problem. So you have a device with you. So if you have a device means we will get some USB cable. So that USB cable needs to be connect. Okay. So as if you have a device only, you can able to connect. See in online, as I told you now, 1 minute, I will just share it again. See, when you are just going to this software, this Arduino.cc, in this, just go to the software and just going for a downloads itself. You will get this option of code online. Just clicking on it, it will redirect to the another page. Just giving there your sign in with Google or something, you can able to simply get your, just give some username and then just give all the things to be confirmed and just give a create account. It will create your account. Okay, so if username is already exist of, so it will give something else. So once it's sign up, you guys can able to get this same Arduino IDE, so you can able to select this. Okay, you can able to start to write this. So you will get, once you guys sign up, it will load this create. Yeah, so you guys will get this. So here you will get the thing. So simply you can type this void setup void loop now. So simply you can type, and then this is for verify and save. So you can able to do this. Okay, I guess you guys are, it's almost 7 minutes done. So let me give these things. Okay. See, when in electronics, when we are starting with the project or something, first we need to go with the process. Okay, so I give total 5 LED like this. So I asked you guys to turn on LED 1, wait for 1.5 seconds, then turn off LED 2, then turn on LED 2, then wait for 1.5 seconds, then again turn off LED 2, like this, processing the things. That's what we are actually, now I asked you guys to create the coders. So when I'm just ask this things to you guys, This is a circuit diagram. Okay, so here I give some pins like 3, 4, 5, 6. So this kind of pins I given here. So this is for positive. So all these pins is connecting with the positive, and all the LED negative pins are connected together and it's connected with the ground. So this is a simple circuit diagram. So when you are just going for the void setup, here I didn't define a variable name. Instead of defining a variable name, as I already told, here I just give a pin number directly. So 2 also output, 3 also output, 4 also output, 5 also output, 6 also output. So in void setup, I just define all these 5 LEDs and what kind of output is there. And then in void loop, first I give a digital write 2 high, 500, digital write 2 low. Then 3 high, 500, 3 low. So 4 high, delay, and then again low. So like this. So like this, I can able to make the multiple LEDs to on off, on off, on off, on off, on off. Okay. So this is how to on and off the things. By using this more than one or two LEDs. So the same concept, if you are going for the little advanced, you can use a void loop. So when you are going for the void loop, I am just applying the for loop. Okay, so for loop, so when you are just going ahead with this void setup, first I just given integer d equal to 100. So it's a kind of simple variable name, and I just define a variable names, sorry, the pin modes, pin and what kind of mode is there. So the very first step is in this void loop, what I just given is a for loop. Okay. So in for loop, I just give a equal to 2, a is less than 7. So a equal to 2, that means I'm just starting with this pin 2. Okay. So a equal to 2, a is less than 7. Okay. So this I am initiating, and this is a condition. And if until this condition becomes false, it will keep on executing this a plus plus. So first step is A is 2. So A will be high and D 100. So this D, it's nothing but here I define a variable name. Okay. So then again low, then again D. So again it will initiate one more thing. So now the A value is 3. So 3 will be high low. Then 4, 4 will be high low. So by using a for loop, also we can able to make. Of course, we can able to use a loops here. So clear guys, any questions? Okay, guys, I guess now you guys can, I give 2 minutes time, so kindly punch your attendance, I guess. So any other questions, guys? So this program is clear, any doubts? Okay, I guess you guys done with attendance. So let's we start with the doubt session. Some people pings for your doubts. Okay, why we write digital right? Okay, in a code, why we are writing a digital right? Okay, see, whatever you are just giving, okay, to your LED or to your sensor, it's all digital signal that we are just going ahead, we are just giving to some electronic device. Okay, so that's the reason we have a digital write. Digital write is a keyword which is denoting that I am going to write some kind of electronic signal or electrical signal or some kind of input output to the particular pin of my Arduino board. So that's the reason, the exact reason of digital write. Okay, so that's what we are using a digital write. So the next thing is, okay, again I will explain this code. So here we are just defining a variable name. Okay, so the variable name, it belongs to integer. So that's the reason I'm using an integer. If it belongs to boolean or float, I used to give a float or something here. So this is a pin number. So as we already told, to which pin I'm going to connect my LED, that pin I need to give here. Okay, 8 or something. Okay, so then here we have a two things. One is void setup and another one is void loop. So in this void setup, we always need to set up your input output. Okay, so we always needs to set up this input and output, and in which pin you are going to connect the input and which pin you are going to connect the output. So in loop, we used to declare the logics kind of things. So in void setup, here we are having a pin mode. Pin mode is a keyword which is used to denote which pin is connected for what purpose. Either this pin. So for example, I'm just giving a pin mode. So I'm just giving two also output because I'm planning to connect into LED. So LED means always output. So we are now, I'm just going to explain you one more code which is used to help you for the connection of sensor. That time you guys get the better understand. So this pin mode, either you can define a variable name here, or you can just directly give your pin number here, and it's an input or output that we are going to declare here. So then in void loop, I'm just giving a digital write. Digital write means what kind of signal I'm just going to give to the particular pin. So for this pin 8, I'm going to give a high signal. High signal means plus. And the next line I give delay 5000. So that's actually milliseconds only. So like when I'm just giving this 5000, it will be going to give 5 seconds gap. So then again it will be low. Then again if I am using delay, then again it will be hold that low for that particular second. So it will be repeat the process. Okay, so this is the code. Okay, so yes, it's mandatory to connect your pin number, so where the LED is connected. Okay, see, 100 means 100 milliseconds only. That's actually yes. And if it's mandatory to declare the pins, because if you are not declare the pins, your Arduino that could not able to understand which pin is connected for what purpose. So that's mandatory. So see, as you guys asked, what will they actually happen if the LED gets switched on? I mean, how it is useful. Okay. See, when there is some indicator needed, okay, right? So if fire sensing alarm, if you are just putting the fire sensing alarm means you need to connect with the LED or you need to connect with the buzzer. So connecting with the buzzer and LED does not going to make any difference in coding and circuit. Buzzer also having a positive minus like your LED, and you are just going to declare the setup and loop there. So you are the same flow only for buzzer as well. So connecting output and input, how to write the code. So that's the main thing we are discussing here. So of course, when you are just processing something, we need to handle the things. Okay, we need to handle the things with the help of your output and input only. So this program will give the basic idea about how to set up an input and output. By using the same method only, you are just going to handle the sensor and all those things with a little bit of modification. So without knowing the basic, you could not able to achieve the advanced level. So that's the reason it's very, very important. Okay. So can we declare all LED pin numbers in one pin mode statement? No, that's not advisable. We should not do that. We need to declare in the different way. That's not actually possible. We need to create an array, but this array kind of things in C programming again will be the complex structure for us, so we won't prefer. We will declare separately. This pin, this mode, this pin, this mode, this kind of things only we will go ahead. Okay, so I hope you guys are clear with these steps. So let me go with the next thing. So the next thing is giving a basic idea about the same connection but with the sensor now. Okay, so how we are going to make the sensor connection with the help of your Arduino. So we are going to deal with UNO only, ultrasonic sensor and the LEDs. Okay. So let me explain the concept. See, this is the circuit diagram. So first I will explain the circuit diagram. So ultrasonic sensor, which is having a four things. Okay, I will explain how the ultrasonic sensor will work. So we have a ground, we have a VCC, we have a trigger, and we have a echo. Okay, so the first thing is I need to first connect this ground and VCC to my Arduino ground and VCC part, and then this trigger and echo I need to connect with any input kind of things, and I am just going to make two output. The two output is an LED red and LED blue I have. Okay, so if some people if my hand is in the particular distance, I will get the LED to be on. If my hand moves above the distance, then I want to make the blue LED on. Okay, those kind of things only now we are going to discuss in this. So when I'm just going ahead with ultrasonic sensor, so ultrasonic sensor is actually going to measure the distance by your ultrasonic wave. Okay, so the sensor emits an ultrasonic wave and receives the wave reflected back. Okay, so when you are just going ahead with your ultrasonic sensor, it's going to measure the distance by the target. Okay, so if this is the object means, so from the object, it's going to receive the distance and it's going to send the signal, and based on the signal it sent, it's going to receive the distance. So distance equal to speed into travel. Based on this formula only, the ultrasonic sensor is working. So L is the distance, T is the time between emission and reception. So it's an emission and it's a reception. So the signal will be emitted to the object and it will be receiving some kind of signal back to the reception. Okay. So based on this emission and reception, the transmit and receive, the ultrasonic wave which is traveling in the air, some kind of reflection will be backed towards your ultrasonic receiver, like this image which shown here. So based on this, so how much distance is there? So distance equal to speed into travel. So based on this formula, we are just executing the things. Okay. So ultrasonic formula, ultrasonic sensor works like this. And your ultrasonic sensor, the schematic name is HCSR04. Okay. So the next thing is the same distance calculation. So like this, all the libraries now I am just defining. The reason I am defining like a library is when I'm going for the sensor and all those things, instead of declaring like a variable name, we can define like a library as well. So hash define trigger pin. So trigger pin, that is nothing but the pin which is actually given here and the echo. Okay. So transmitter and a receiver. Okay, so this trigger pin is 13 and echo pin, the receiver will be your 12, and LED I am just giving L1 11 and LED2 I am just giving as a 10. So as defined, instead of using a variable name, I can use this as defined as well. Then this is the setup. So serial dot begin. So 9600. Okay, this I will explain what is the serial dot begin 9600, that I will explain here. See, pin mode. Okay, I just give a trigger pin and output, pin mode echo pin input, and pin mode LED output, pin mode LED2 output. So see here, this trigger pin, LED, LED2, all these three things I define as a output. Okay, and the echo pin I define as a input. Okay, so output and the input. Okay, so the thing is actually I'm just defining what are the output and what are the inputs that I want to handle. So again, in a void setup, we have one new thing that's nothing but a serial dot begin, and pin mode. Again, we are just defining input and output only. So in the void loop, what I'm just given here is long. So long is another variable. It's a kind of data type. It's not we can define as a variable. It's a kind of data type, which is going to store the data type 32 bytes. Okay, the 4 bytes. So it's again C programming data type only. Duration comma distance. These two things is your long integer. So digital write trigger pin low. So if my trigger pin is low means 2 microseconds I am making a delay, and I am just making my trigger pin high. And my trigger pin high, again I am just making a 10 microseconds delay, and again I am making a trigger pin low, and again I am making a trigger pin high. Okay, so as I am making my trigger pin low and high, low and high, so the next thing is what I need to do is I need to apply if distance is less than 4. Okay, so distance duration divided by 2 divided by 29.1. So this is that constant value I am just handling. Duration divided by 2, and then if the distance value is less than 4 means my LED will be high, and which LED will be high means my digital write LED will be my red LED will be high, the LED2 will be low. Else, if my distance is greater than 200 and less than 0, I want to print out of range. Okay, so else I will get the distance to be printed in centimeter, and this process will be repeat for again and again and again. Okay, so we need to apply your if else condition towards here. So here you guys just understand, when you are just going ahead with even the sensors, we need to make two things. One, in void setup, you need to define your input and output. Then in void loop, you need to apply the if else for loop, those kind of conditions, calculation, everything we need to define here. Okay. As going back to this, your serial begin. So there is some serial begin which is there in the code. See, this sensor output, when you are connected the sensor, we need some monitor to monitoring the things. Usually any kind of sensor outputs, even in industry, we used to monitor the things. Okay, so for the monitoring purpose, nowadays in industry we have a cloud monitoring, but as you guys are using that practicing the session, we have a serial monitor here. See this kind of this symbol which I'm just selecting here, this is a serial monitor. When I'm clicking here, I can able to get how much centimeter my hand is away from my sensor. So to get this kind of distance, I can able to go ahead with this serial monitor. So this serial monitor, it's having some baud rate. So based on this baud rate only, my monitor will work. So that serial begin 9600 means my serial monitor will work based on this baud rate. So for that perspective only, we are just to define serial dot begin 9600. So this serial monitor is mainly used for the monitoring purpose, and this ultrasonic sensor is used in a lot of applications. So for example, you have a car, and there is some target is there. So what's the distance between the target and your car? So for the parking assistant, those kind of things, we can able to use the ultrasonic sensor. So this is the way that we can able to connect with the sensor. Now coming back to sensor, sensors are mostly the input only, but in the sensor pins we will get the output as well, because in ultrasonic we need to give a signal and we need to receive the signal. So giving and receiving, so transmitter receiver, it's mandatory for us to handle the things. So the next thing here is we used to go ahead with the concept selecting the sensor. See, when you are selecting the sensor, uh, we need to first know about what's your requirement. So if you want to make the automatic door open and close, we need to select the motion detector sensor. So this car parking, those kind of thing, we need a ultrasonic sensor, and for the temperature we need the temperature sensor, and for the light variance we need the LDR. So this kind of things we always needs to think. Okay, so based on your requirements we need to research about what kind of sensor will help us. Okay, so I hope you guys may get the basic idea about writing the code for Arduino and the circuit diagram. So tomorrow we'll do the same thing Arduino, but not with Arduino board, but with ESP8266. So I will give more idea about how to connect ESP8266 and this Arduino. So you guys will get the better ideas. Okay. So as your question is how many LEDs in one Arduino module is controlled? See, we don't have the limitation. But again, coming back to the same thing, if you are choosing Arduino UNO, you can able to give 13 outputs. So probably you can able to connect only 13 LEDs. So that input and output, the pins matters. So based on the pins, we can able to meet up the things. Okay. So any doubt, guys? Okay. So just giving some other basic idea about Arduino boards. See, our Arduino board, as we told, it's an open source electronic platform board which comes with your hardware and software as well. So this Arduino board comes with Arduino programming language. That's nothing but your Arduino IDE. So mostly students hobbyists will start with this Arduino IDEs. Okay. So the reason we are going ahead with your Arduino is uh, small kind of projects, only for the small kind of projects it's actually best. uh, Before we are starting with any high level boards, if we handle the small kind of boards, it will be helpful for us to understand the thing. So for that perspective only, mostly we will start with Arduino. But industry usage is very, very less in Arduino, apart from the small circuits. So for example, sometimes in Amazon, we used to get the automatic fish feeding machines. Okay, so that's all you can able to made up with Arduino, because that's not going to do a lot of performance. So for those kind of things, you can choose Arduino. Okay, so why we are telling Arduino is a open source hardware. Okay, see, open source hardware means this is actually not only for Arduino, for open source hardware. So when we are just dealing with something, actually I'm not sharing the screen. The reason is it's a kind of theory which is a interview question, so that's the reason I'm not sharing the screen. So the reason of open source hardware is, see, the principles and the approaches for the principles and the hardware parts is shared with everyone. Okay, that's what your open source hardware is. Okay, you guys can able to get your Arduino board in from the local market itself. So that's not a big deal. So but in local market we will get a lot of duplicate Arduino boards. Okay, those things are known as a cloning Arduino boards. As you guys are going ahead with your basic practicing, that is more than enough. But the original Arduino board, which cost around 700 to 800, but in this markets we can able to get 400 to 500. That is more than enough. So the programming language which we can able to use in this Arduino are Python, C, C++, AVR, G++. Those kind of softwares we can able to use. You can't able to use other IDEs apart from Arduino IDE, but AVR Studio is possible, but that's not advisable. So simply use Arduino IDE to go ahead with your Arduino stuff. Okay. So .ino is the extension for your Arduino ideally. Apart from the serial monitor which I showed with you guys, you can't able to get the things. See, I'm not taking any theoretical concept. I'm just telling some of the theory inputs. That's why I didn't share the screen. Okay. So the concepts which I explained is a kind of summarizing the things. Like from the beginning, whatever I just explained, I'm just summarizing the things, nothing else. See, cloud data monitoring, machine to machine interaction is all I will explain tomorrow along with the ESP8266, because this cloud data monitoring is something instead of the serial monitor, we need to connect with the cloud. So from the cloud, we need to monitor the things. So how much the temperature is this, all those things. Probably tomorrow or day after tomorrow, I will get with some videos and I will explain the things. So the next step after the Arduino code means you can't able to move to the higher level in industrial grade programming. You can able to move to the next level board, that is nothing but the Raspberry Pi. After Raspberry Pi, we can able to move to the higher level grade programming. Okay. So first you guys needs to handle the simple boards. So for example, first, if you don't know the basics of programming, you could not able to develop the application. So now we are just starting with the basics of the things. After that only you can able to go ahead with the advanced things. So for that perspective, first we need to start with the basics Arduino. So once you handle one board, so later onwards you can start to handle the next boards. So that's the concept. So any other questions? Okay, how to retrieve data from online? See, retrieving data from online, having a different criterias. Okay, so for example, if I am connected, first my device needs to connect with the cloud. Okay, then we can able to get the data from online with the help of coding only. So we need to give some kind of API authentication to retrieve the data. So that will be different stuffs. Okay, so that will be the different things. So retrieving the data, again we need to give the cloud credentials, and again we need to handle with coding only we can able to retrieve the things. So any other doubts, guys? Okay, then fine. Tomorrow we'll discuss little bit of cloud and node MCU part. Okay. Okay, guys, then we'll see you tomorrow. Thank you. Bye.